Welcome to question 5. Okay, ball is launched from the origin. So this is a projectiles question. You did want to look through one of these. With speed 1 meter per second, is velocity making angle of theta. I guess they're going to tell us what theta is, are they? No. Find the horizontal and vertical displacements. Particle at time t. You should give your answer in terms of theta and t. So what we've got here, we've got 1 is the speed, right? And then we want to split this, that's theta, into vertical. So this is for projectiles like this. You remember you're thinking vertical and you're thinking horizontal. How are we doing for space? That's all right, isn't it? Okay, so the vertical component is going to be this. So opposite, isn't it? Opposite the angle. So hypotenuse times opposite the angle. 1 SOT, so sine theta. And then, there we go, see if this guy's working. Horizontally, we've got 1 cos theta. Okay, that's because we've got a speed of 1. That's why it's 1 for both of those. Right, so that's its speed. Now, let's have a look. We want to find the displacement. So SUVAT. Vertically, S, that's displacement. That's what we want. Initial velocity, sine theta, 1 sine theta from here. Final velocity, we don't know. Acceleration is always, let's take up to be positive. Let's take up to be positive. So minus 9.8. And we're after time t, right? After t. So there you go. That's vertical. So S equals ut plus half at squared again. S equals ut plus half at squared. We want the vertical displacement. So S is equal to sine theta times t. So our answer is going to be in terms of theta and t plus a half a. So half times minus 9.8 is minus 4.9 t squared. Jobs good un. So SUVAT. We're still filming, yes. So horizontally, what have we got? We're looking for displacement. U, initial velocity, is 1 cos theta, or just cos theta. Now, we actually know that final velocity is also cos theta, because we know acceleration is 0 and time is t. So we've actually got all of them for horizontal. What do we want t? Which is going to be the easiest one here? V equals u plus at. Is that a bit of a cop-out? What do we want? We want S, though. Should we use the same one? S equals ut plus half at squared. Actually, yeah, because that simplifies, doesn't it? A is equal to 0. Why is this true? Because there's no acceleration horizontally. We've only got acceleration due to gravity. This is the big thing for projectiles. So that becomes 0 because A is 0. So we get S is equal to cos times t. I haven't read the question, but I'm looking into that, and it's cos, and I'm thinking we've got t's. Simultaneous equations. I'm thinking we might have to use the fundamental. Let's see. Okay. What about B? Let's keep going. Show that the horizontal distance traveled by the particle before it hits the ground. So the horizontal distance is sine 2 theta over 10. So we want to show that the horizontal distance before it hits the ground So, okay, so essentially as it hits the ground, what's its horizontal moment? So it's like going like this. The moment when it hits the ground, how far has it travelled? It's 5 marks. That's a lot of marks. So what are we saying here? Well, when it hits the ground, we know that vertically, what happens when it hits the ground? S is equal to 0. So we've got, from this guy here, we've got, so vertically, 0 is equal to sine theta t minus 4.9 t squared, right? So, and what do we want? We want to work out, what's it asking for? It wants horizontally to find S, the distance travelled. So we want, questions asked for S equals cos theta times t. So we want to get an expression for t. So this is true. Let's factorize it. T sine theta minus 4.9 t. So if it's going to be true when t is equal to 0, or t is equal to sine theta over 4.9. So if we make this 0, so what we're saying is sine theta minus 4.9 t is equal to 0. If we rearrange that, make t the subject, we get that. So that must be here. So we got 0 at the beginning when we're firing off, t equals 0. And then later, when t is equal to sine theta over 4.9, we hit the floor. So how far have we travelled when we hit the floor? Let's substitute this guy into here. So S equals, G is equal to 10. G is equal to 10. 10. 5. 5. 5. 5. 5. There you go. All works. Everything else is fine. I was wondering where this 10 came from suddenly. Okay, so cos theta times sine theta over 5. Now, well, but we've got this sine 2 theta. We're not using the fundamental trig identity. We're using the double angle formulas. So we know that sine 2 theta is equal to 2 cos theta sine theta, or sine theta cos theta. Multiplication is commutative. Right, so we're using that, aren't we? So hang on, but we've just got cos theta sine theta. So that means sine 2 theta over 2 is equal to cos theta sine theta. We've got cos theta sine theta. So we've got S is equal to cos theta sine theta over 5. So that's the same as sine 2 theta over 2 over 5, which is sine 2 theta over 10. If that's lost you a little bit, just work on your fractions, right? This is the same as cos theta times sine theta times 1 over 5. And it all works out. Okay, describe one limitation of this model. What's the limitation? Limitation, no wind resistance. The ground won't be flat. Okay, let's write some of these down. Wind resistance. Ground not entirely flat. What else have we got? I'm interested to see what you say for this one.